So the last way that we're going to talk about solving these systems of equations after graphing and elimination is through substitution. And you may use a bit of substitution at the end of after using elimination to plug things back in. But let's look at a pretty basic problem to get a feel for it. So if we're given a system of equations that looks like this, 4x plus 2y equals 7, and y equals 5x. Well, what this is actually saying is it's saying y is equal to 5x, and that's the same y that's in the first equation. And the x is the same x. This is a system of equations. And if you were to, imagine this on a Cartesian coordinate plane in 2 dimensions, it's the same x coordinates and the same y coordinates that you're using. So what we can actually do is we can take the 5x, which we know is equal to y from the second equation, and we can replace that y in the first equation with that 5x. So what that looks like is this. So if we rewrite this first equation, we can say 4x plus 2 times 5x is equal to 7. Because all we did was replace the y with a 5x, because they're equal. So then we're left with 4x plus 10x is equal to 7. So 14x is equal to 7, or x is equal to 1/2. Okay, so now we have x is equal to 1/2. We can take that, we can plug it back into any other equation that we have. This one is obviously going to be the easiest one, the second equation. So what we can do is take that x equals 1/2, plug it in, and we get y is equal to 5 times 1/2, or y is equal to 5 halves. So our solution would be 1/2 comma 5 halves. Okay, so that one's pretty simple. Let's look at one that maybe involves a little bit more to it. Changing colors here. Okay, so sometimes it's better to use elimination, sometimes it's better to use graphing, sometimes it's better to use substitution. But for the most part, you can usually use any method and it should work out pretty well. If I'm given this system, 2m is equal to negative 4n minus 4, and 3m plus 5n is equal to negative 3. All right, so we have a system of equations here, and we can use substitution to solve this. Maybe elimination is better. You can determine that. It might be, it might not be, but let's use substitution to solve this system. So first thing I'm going to do is I need to solve for one of the variables. And to me, the easiest variable to solve for right now would be the m in the first equation, because it's almost isolated already. So all I have to do is divide everything by 2, and I'm left with m equals negative 2n minus 2. Okay, well now I can take this expression and plug it into the second equation. So 3 times the quantity, negative 2n minus 2, plus 5n is equal to negative 3. So all I did was take this expression that we know is equal to m, and then plug it in for m in the second equation, and then we have this. So I distribute this 3, and I'm left with negative 6n minus 6 plus 5n is equal to negative 3. Okay, now let's combine some like terms. I bring the 6 over to the other side. That leaves me with 3, positive 3. And then the negative 6n and the positive 5n combine to make just negative n. So that means n is equal to negative 3. So if I plug this back into my first equation, or we can pick any equation. We can even pick the equation that we solve for, m equals negative 2n minus 2. That one would be perfect. So we have m equals negative 2 times negative 3 minus 2. So that's 6 minus 2, which is 4. And we're left with m equals 4. So our solution could be, if it was m comma n, if it was m comma n is equal to 4 comma negative 3. And that is a little bit more complicated substitution because we actually had to distribute and plug in a quantity into our new variable. But still the same steps and not that much more to it.